moles of acid is. Okay. And we're looking for concentration of sulfuric acid. Okay. The volume, which is, what is the volume? 10 mils, right? All right. And then we have to do it the exact same thing. Three more times and then just take the average. So we'll do it one more time. Just pick whichever one you want, doesn't really matter. Sure. And then just do it quickly. And then we'll take the average and then we'll just call it there. Well, yeah, but I don't want to waste time. Because, yeah, you're supposed to do it that way, but I mean, we know you know how to do it, so it's fine. All right, so just check the answer though. Ooh, this is a good question. So table 6, that's over here. Let's grab that. Okay, let's see. Phenolphthalein indicator was used in the titration of 25 mL of acid solution of unknown concentration. The acid was treated with standard solution of sodium hydroxide. The results are given in table 6. What volume of sodium hydroxide would you use to calculate the concentration of acid? Explain your reasoning. So what volume would you use? So you see, basically they did 4 trials. Same thing, same as our previous example. Yes, find the average, that's right. Yeah, that's it. The only thing is you would exclude this one. See how it says dark pink? So it's an outlier. So you wouldn't include it. You didn't only include the light pink ones because clearly you made a mistake or someone like made a mistake in this one. So you wouldn't use trial two. Oh, and I just realized. So we made a mistake in the previous one. We were supposed to add up all the 4 volumes and take the average and use that. So we didn't have to we didn't have to do the calculations that many times. You can just take the average initially and then use that volume. Do you understand? Yeah, because it's the same math, but this way is shorter. So yeah, so instead of like let's not waste time. So just like with this one, add these 3 volumes and divide by 3. That should be the answer. So 20.53 plus 20.3 plus 20.65. Add them, divide by 3, and then the average. So that's 15, that's 3, that's 18, that's 20. So it should be 20.49 mils, I think. Go ahead. So hydrochloric acid can be neutralized with sodium hydroxide or sodium carbonate. Write a balanced chemical equation for each reaction. That's the easy one. What about this one now? Let me know when you're done. Yeah, so just remember carbonic acid just breaks up into these two pieces here. So a lot of students forget that. They're like, oh wait, that's an acid. And yeah, it doesn't make sense, but no. Yeah, exactly. But here we do. We do have water, and we have carbon dioxide gas, and we got sodium bromide. All right, we're good. Like this Erlenmeyer flask. Okay, so for this question, they're asking us to create an experimental design to fill table 7. So they want us to react magnesium with all these different acids, right? So I would have a flask with each of these acids, and obviously you'd keep the concentration of the acid the same. So all the concentration would be, I don't know, let's say 1 moles per liter, whatever, 0.5, whatever you want it to be. So, but keep it constant between all of the acids. Have the volume also be constant. So let's say 10 mils for all of them. And then the magnesium is also going to be constant. So let's say 10 grams of magnesium or something. And then I would take my 10 grams of magnesium. Remember, magnesium is solid, right? It's a solid metal. So I would take my 10 grams of magnesium. Now, before that, I would add an indicator to each of these acids. And that way, sorry, the flask. Yeah, it's titrant. Yeah. So you always add in the titrant, which is in the burette. Yeah, sorry, say it one more time. Sure, if that's what it's called. I've forgotten. You're probably right. So yeah, so you add the indicator to the flask, and then that will change the color of the flask. Because normally acids are clear and colorless, and they look like water, so you can't really tell. Like, so that's why you add the indicator, the appropriate indicator, and then it'll change it to a color, whatever, pink, blue, red, whatever it may be. And when you add the magnesium to the acid, what will end up happening is obviously you have a stopwatch, and you will run the timer and check for the time, and you would stop the time for when the color changes for your acid, because the magnesium is going to react with. Wait, does the magnesium react with these things? I'm trying to think. Is magnesium going to change the pH level? I'm curious now. I'm not sure if magnesium will change the pH level. If you add magnesium to HCl, what happens? Yeah. Yeah, it will react. Yeah, an acid reacts with metal. Yeah, it eats it up. Okay, so it would get dissolved. So then what's gonna happen? You time it, and then when the color changes, then then you record that time, and then that will show you how fast it took, how long it reacted for with the magnesium. Or if it's not the color change, sorry, I made a mistake. I apologize. No, it's not color change that you're reacting for. Sorry. You're looking for the actual physical magnesium disappearing and melting. That's what you're looking for. Apologies. No. So color change is it's a pH indicator, so it tells you when the pH has changed. But we're not looking for that right now. We're looking for it reacting with magnesium. So acid and magnesium, you'll see like bubbles and like magnesium melting. So yeah, so that's what you add the magnesium. You basically start the timer, and then when you see like the smoke or the bubbles stop and like there's no more reaction, that's when you time it, and that's when all the magnesium has been reacted. So there's no indicator. Yep. Yep. Yeah, exactly. Yeah. They even tell us the acidity is 0.1 moles per liter. It even tells us that right above the table 7. So yeah, so they kept the acidity the same. You keep the volume the same, and then you keep the mass of the magnesium the same. So those are all controlled variables. And then your independent variable is, I guess, time. Yeah, I don't know, mass of magnesium or something. I'm not sure. I'm guessing the mass of magnesium or something with the reaction. So the control would be the acidity of all the acids, the volume of the acids, and I guess the mass. I guess the mass of magnesium is also fixed, so that would be a controlled variable. That's also fixed. Yeah. So yeah, I'm not sure what independent dependent would be. Independent is definitely time, and then dependent would be, I don't know. I'm guessing mass of magnesium. I really don't know. That's not. Yeah. So you wouldn't be doing calculation. It'd just be observation time, right? So the once the reaction has stopped occurring, the fastest reaction would be the fastest one to react with magnesium. Do you get it? It's just time. You're just recording time. So once all the bubbles have disappeared, and there's no more like bubbles, and there's no more like like reaction occurring, then you know that all the reaction's done. So yeah, so some acids are going to react super fast, and you're going to see a really like aggressive bubbling, and it's going to stop fizzing. And then others, you're going to see the magnesium slowly still there, and slowly bubbling for like an hour. Because it's such a Well, no. They're not asking you to solve anything right now. They just ask you to design an experiment. Of course you can. That's literally what chemistry is. This is experiments. We literally do this in real life. This is how we figure stuff out. So somebody back in like 1,000 years ago did this, or hundreds of years ago, whatever. Well, no, but that's the whole point of labs. You have to observe. Yes, because that's a lab. That's what labs are. You're always observing. When it comes to theory, then yeah, then you're calculating stuff. Without more information, no. Yeah. All right. Are we done, or do we have time for one more? I don't know. Yeah. Oh wait, no. I think no. I think we are done. Actually, sorry. Yeah, because we started before 6:30. I think. Yeah, I'm pretty sure we did. Or I could be wrong. I don't know. Yeah. Okay. All right. Did you have fun?